Thank you for joining this lesson. We're going to discuss commercial arithmetic. Number 3. A businessman deposited 80,000 Kenya shillings in a savings account at the beginning of the year, which pays 10.5% interest per annum, compounded quarterly. Very important information. Find the amount in the account at the beginning of the 5th year. Therefore, we are supposed to read this question very carefully, because we are told at the beginning of the 5th year, then it means after 4 years. Therefore, we have 4 years here. Remember the rate, which is 10.5%, is compounded quarterly. That means if this is per annum but compounded quarterly, then it means we should divide by 4 and know after a quarter a year what is the rate of compound interest. And this is 2.625. 2.625%. Then the other thing is N, the number of interest periods. These are 4 years, and after every 4 years, or within 4 years, we have 4 quarters. Therefore, the number of interest seasons are going to be 16. The number of interest periods are going to be 16. Now, according to the compound interest formula, we usually say that the amount after a given time is given by principal into 1 plus rate, which is a percentage, raised to n. Therefore, we're going to say that the amount after 4 years is going to be 80,000 into 1 plus a rate of 2.625% raised to 16. So I can now compute this, whereby I will take 2.625%, then I take 1 minus that value. Now I will raise this one to power 16, then I multiply the answer by 80,000. One plus 2.625 over 100. Then I raise to 16. Then I multiply by 80,000. This is 121,099 Kenya shillings. 0.99 Kenya shillings. So that is the amount after the given years. The next question is talking about two quantities Q and R are such that Q varies partly as R and partly varies as the root of R. So I must first of all interpret that statement mathematically, and I will say if Q varies partly as R, then the other part, it varies as the square root of R. Then it means I can now write it like this. I introduce a constant or two constants such that one constant is K times R and another constant can be C times the square root of R. Then I interpret more. We are told that determine the equation connecting Q and R, given that Q equals to 500 when R is 16. So R 16, so 16 times K, and the square root of 16 is 4. Then again, Q is 800. Q is 800 when R is 25. So 25 times K. The square root of 25 is 5 times C. Therefore, these are two equations. This is 1, this is 2, which I'm going to solve simultaneously. To solve simultaneously, I can prefer what we call the substitution method, whereby from equation 1, from the first equation, we can say the value of C by taking 4C equals to 500 minus 16K. Then the value of C is going to be 500 out of 4. This is 125 minus 4K. Therefore, I substitute this in equation 2. Therefore, equation 2 can be rewritten. 800 equals to 25K plus 5C. Instead of C, we write 125 minus 4K. Therefore, 800 equals to 25K plus 125 by 5 equals to 625 minus 20K. Therefore, this is a 5K equals to 800 minus 625, which is a 175. So the value of K is going to be, when we divide by 5 through, 35. The value of K is 35, and the value of C can be given from this equation. C equals to 125 minus 4 into 35. So the value of C is going to be, when we take 125 and we subtract 4 into 35, we get negative 15. Therefore, now the equation connecting Q and R is going to be this one, but now the constants have been found. Therefore, Q equals to K, which is 35, R plus C, which is a negative for this case. Therefore, so negative 15, the square root of R. So this is the equation connecting P and Q. We also have another question here. Yeah, we can work on it. It's on a proportional division of a line. We are told that the position vectors of points A and B are as shown there respectively. Then a point R divides AB externally in the ratio 3:1. Find the position of vector R in terms of I, J, and K. Therefore, we're going to say, let's say this is our origin. Then we will have our A, our B, and our C. Now we are saying that externally, not C, but point R, sorry. Point R. It's point R. So we will say point R divides in the ratio 3:1. So externally means from A to where R is, we have 3 divisions. Then to where B is, we have 1 division. That means if from here we have a 1, 2, 3 divisions. Then we have the 3 of them, then 1 division. So we will be having 1 division there and 2 divisions here. In other words, B divides AR in the ratio 2:1 internally, while R divides externally AB in the ratio 3:1. Another way of writing 3:1, the examiner could have omitted the word externally, but simply introduce the ratio 3:1. It would mean the same. Now I want us to apply what we call the ratio theorem, assuming that this is ratio M and this is ratio N. We usually say the coordinates of B are given by, when we take ratio M out of the total ratios, then we multiply by vector R, and we add ratio N out of the total ratios, then we multiply by vector A. So that is the ratio theorem in general. So we can now apply it and say the coordinates of B, which are already known. The coordinates of B are -2. Remember this -2j and -2i and j. So the units are -1, -2 and 1. So we're going to say -2 and 1 is found by ratio m is 2 out of 3, which is the total. Vector r is unknown, plus 1 out of 3 vector a, which is, okay, the third is 0 here, so we can also have our z, sorry, yeah, because this one is in 3 dimensions, but this one is in 1, therefore it means the z axis has 0 units. So this one is going to have 3, -2 and 4 according to the position vectors provided there. Now I'm allowed to find the unknown here, so I can say -2 equals to 2/3 x plus 1. This is 2/3 x plus 1/3 by 3 is 1. Therefore 2/3 x equals to -3. 2/3 x equals to -3. Therefore x is going to be by 3/2 by 3/2. So -3 times 3/2 is going to be -4.5. -4.5. Again, I will say this is 1. 1 equals to 2/3 y plus -2/3. -2/3. Therefore, we can get the value of y by saying when -2/3 is taken to the other side, we will have 1. We'll have 1 plus 2 out of 3. That is a 1 and 2/3. Then we multiply by 3/2 to remain with y. That is going to be 2.5. 2.5. Then we are also going to say that 0 equals to 2 out of 3z plus, this is 4/3. So the value of z will be given by, so we will say -4/3 to the other side. Then we multiply both sides by 3/2 to remain with z. So -4 out of 3. Then we multiply by 3 out of 2. That is going to be -2. Therefore, find the position vector of r in terms of, so we're going to have -4.5 vector I plus 2.5 vector j minus 2 vector k. So this is the position of vector r. The position of vector r is calculated as shown. Thank you for following. Subscribe and share.